Yeah, sorry for the delay. A very good evening, one and all. I, being the HOD of IT department, Dr. V. Vasudha Rani. For today's resource person, Dr. K. Raghavedra Kumar garu, and our beloved principal, sir, Dr. CLV RSV Prasad garu. As we are doing this FDP in collaboration with AU, I'm inviting Dr. Kunjam Nageshwara garu, HOD ITCA, Andhra University. I welcome you all for today's FDP inaugural session. And as this FDP is titled as Sustainable AI and Large Language Models Technologies in the Domain of Health, like we have a long process in selection of this topic, as this is one of the most growing research domain. And nowadays, for all the academicians, the research is inevitable. We could choose this topic. And also keeping in view that for the body upcoming doctorates, to give them a new thought process that leads to find a new problem statement for their research work also. And this, like here, totally altogether, three domains, three career paths we are covering here. Started with a session on introduction to generative AI, and which in sequence with machine learning applications in the domain of health, and then deep learning models in the domain of health, and which in continuation with that large language models, which is the very buzzy and which has more profound applications nowadays in the research. And with this, I welcome all the dignitaries and all dear participants from various regions of the AP and other states. I welcome you all for all the 5-day FDP. I request all of you to have consistent learnings. So we are hoping that after this 5 days, you people will enrich your knowledge in the domains, and the practical learnings support you in making some results and conclusions in your research work. All the best to all participants. I thank Dr. Raghavendra Kumar garu once again for accepting our invitation to join as a resource person for the day one. Thank you. Lakshmi ma'am. Ma'am, take over. In this regard, I request our principal, sir, Dr. CLV RSV Prasad garu, to address the participants. Sir, please, sir.
Thank you, Dr. Vasudha. I hope everybody can hear me.
Yes, sir.
Yes, sir. You are audible, sir.
Audible. Okay, thank you. So, good afternoon to all of you. At the outset, I would like to compliment the departments of information technology and computer science and ML for having initiated this faculty development program in the right direction. And the title that is chosen, that is Sustainable AI Applications and LLM Technologies for Health Data Analytics. I think it is a very apt area. And I'm very sure that the learnings out of this faculty development program to all the faculty members will be a rich enlightenment, and this will help further the students to get through. So as a part of the tradition, the GMI Institute of Technology does a lot of faculty development programs to ensure that the faculty gets updated with the latest technologies that are happening in the industry, and in turn to disseminate that to the students who are upcoming. So in that line, this initiative has been taken up, and I'm sure that all the participants who are there will have a great takeaway at the end of the 5-day stage program. And in fact, I don't have much to talk about the topic because I'm completely let us say I'm out of the box of this element. I'm from basically mechanical, so I may not talk much, but I'm very sure that this program will help all the participants. And once my sincere advice to all the participants and also to other people, our own faculty members, is to consistently participate and be active in the workshop. I mean, into the faculty development program. So I request all the people to take this seriously, participate in full length, and also be active. Further, I'd like to thank the resource person, Dr. C.H. Raghavedra Kumar, Associate Principal Engineer, Concentrics, and Dr. V. Valli Kumari, Professor, Department of Computer Science, and Dr. B. Santosh Kumar, Professor and Head of the Department from Guru Nanak Institute of Technology, and our own faculty members, and one of our senior alumni, Mr. D. Srikanth, a senior staff engineer from Google, and all other resource persons, ultimately for kindly accepting to be a part of this program and to be a resource person. So I once again thank all the people who straightaway accepted our request and who are helping us in making this program a grand success. So wish you all the best. Good luck.
Thank you, sir.
Mahalakshmi, I think you are on mute. Some problem is with your mic.
So which a network issue and
Late, sir, late.
and take off now, Lakshmi.
Yeah, there is some problem.
Vasudha madam, next hour invite chain.
I think there is some problem, technical problem.
Yes, sir. Am I audible,
No.
sir?
Yeah,
audible.
Ramya, you
can.
continue.
Yes. A very good evening to one and all. I am Ramya from IT department, working as assistant professor in the GMR IT. Now I have a brief introduction regarding our speaker, Dr. Raghavendra Kumar Chunduri. It is with great pleasure that we introduce Dr. Raghavendra Kumar Chunduri as distinguished professional bridging the reliance of academia and industry with profound expertise in data science, software engineering, and advanced algorithmic techniques. Dr. Raghavendra Kumar brings over 14 years of global experience, seamlessly blending his roles as skilled researcher and IT professional with a robust background spanning both industry and academia. He has amassed invaluable insights and capabilities, contributing significantly to the fields of neuromorphic computing, deep learning, big data, and machine learning. Currently serving as a senior lead engineering at Concentrics Corp in Omaha, Nebraska, USA. Dr. Ravendra Kumar empathize excellence in research and development. Concurrently, he holds the esteemed position of postdoctoral research fellow at the University of Colorado, USA, within the Department of Electrical and Computer Engineering. His dedication to advancing knowledge is further underscored by his role as Secretary for the IEEE Nebraska chapter, showcasing his commitment to fostering collaboration and knowledge sharing with the academic community. His proficiency is a large of state-of-the-art tools, technology, including R, Hadoop, MapReduce, and Selenium, among others, underscores his ability to navigate complex data landscapes and drive innovation in software engineering and data science domains. And Dr. Raghavendra Kumar's expertise extends beyond theoretical frameworks as evidenced by his hands-on experience in conducting automation feasibility analysis. In addition to his expensive profile, that academic achievements, Dr. Ravindra Kumar Chundiri's contributions are underscored by his impressive citations metrics with 73 citations to his name. Dr. Ravindra Kumar has established a commendable H index of 5 and indicative of impact and significance of his scholarly work Further, his I-10 index stands at 3. We are delighted to invite Dr. C.H. Raghavendra Kumar to a thought-provoking session titled Introduction to Generative AI Applications and Challenges and Relevance to the ChatGPT. I hand over the session to our speaker. Please welcome, sir.
Thank you, madam. Yeah. So, yeah, shall we start the session, madam, or shall I start the session? Madam?
Yes.
Okay. Yeah.
Yeah, Raghavendra Kumar, you can.
Dr. Raghavendra Kuchundur, you are right now in Omaha.
Yes, sir. Yep. I'm in Omaha.
I think you are in early hours. So thank you very much for taking the risk of taking your early hour time.
Oh, no problem, sir. Yeah.
It's almost morning 4 o'clock.
I think so. It is right now at 4:45 in the morning. So.
4:45 early in the morning. So thank you very much for taking your early hour time.
Yeah, no problem, sir. Vasudha madam is my engineering professor, so I don't have
So
any issues.
that's what the other day she is telling.
Yeah. So.
Yes, sir.
Please go ahead. Please go ahead. Please go
Yeah.
ahead.
Okay, sir. Yeah. So, hi all. Thanks for providing me this opportunity to discuss about the generative AI and some of the challenges and some of the issues that we are facing with the generative AI applications and some of the research areas where or some of the research problems that one can take upon in this particular area. So in the recent times, right? So AI, though AI is an old traditional technique or traditional landscape, the recent developments in the field of AI is creating lot of hype, intensity, and lot of excitement towards the computer science world, and towards the and creating an anxiety to the researchers, especially in the area of big data, machine learning, and data science. So, let's start with what is AI, what is traditional AI, and then what are the recent developments in the landscape of artificial intelligence, what is generative AI, and how the traditional AI is different from generative AI. And let's discuss some of the open issues that we have in the generative AI based applications, like OpenAI's ChatGPT. And then finally, in the last during the last couple of minutes in the session, let's go with the creating a sample GPT using the OpenAI GPT and play with it and see how it responds to our questions. So I'm mainly in my session, I'm mainly focusing on explaining what is artificial intelligence, how this artificial intelligence or the traditional AI is different from generative AI, and a brief introduction to large language models, and then the existing issues in the current generative AI world, and what are the research areas that one can take upon while understanding this generative AI. And then finally, the OpenAI demo on creating a sample GPT and how we can play with it. So to start off with, artificial intelligence is the old traditional uh, computing technique that exists from several years, but because of the recent developments in the area of large language models, machine learning, and deep learning, so AI has gained a lot of attention and anxiety and lot of intensity among the computer scientists and researchers. So the main purpose of any artificial intelligence is to develop a computer system that is capable of thinking like a human, that is capable of performing complex tasks like how a human do, with a specific with the specific inputs, with the specific training, and developing a specific set of rules based on different outcomes, and based on different hypotheses. It is the artificial intelligence application is trying to replicate the human actions or human activities. I'm sorry. And AI can be, as I mentioned, AI can be used in various situations that typically require human cognitive abilities, such as problem solving, decision making, and taking some based on an input, giving some output, making predictions based on the data that is trained. So in all of these areas, AI is primarily used. So there are some of the real-time examples where AI can be used in our day-to-day life. Like recent days, if we see the virtual assistants like Apple's Siri or Amazon's Alexa, and then autonomous vehicles like Tesla. So they are all developed based on the AI rules. So a set of predefined rules using which the models were developed, and they are heavily used. And there are also other examples where chatbots, text editors, and whatnot, everything in these days is right now having some AI application deployed into it. Even the vacuum cleaners, everything is deployed some AI application into it and performing their day-to-day tasks using the techniques of artificial intelligence. So now let's discuss what is generative AI and how it is different from the traditional AI. So generative AI is the next generation of artificial intelligence that can create something new. So imagine you have a friend who is really good at writing or telling stories. So here your friend is a not a human being, but imagine he's a bot, he's a chatbot, or he's a robot. So what he will do is, like, whenever you give him some inputs, what he'll do is, like, based on your inputs, he'll gather all the information from his trained knowledge, and he'll try to create a new output. Or if you give him some partial story or some partial text, what he'll do is, like, he's going to create the new content, or fill the rest of the content based on the input that you have given. So a generative AI is something that is totally different than traditional AI, where you create some contents, or where you create contents based on the input that you have given to these systems. But whereas in the traditional UI is more likely the training based, where it is mainly used for a specific task based on what you have teached or what you have taught to the particular AI model. But here in this case, the generative AI is something different, which is the next generation of artificial intelligence that can create something, some new content based on the inputs that you have given. Okay, so in today's world, right? So with the world running behind the generative AI and large language models, so it can any generative AI application, it is not only about story generation or filling up this text. So it is not only generate the text, but it also do a lot of jobs like understanding the images, understanding the audio files, and then interpreting some knowledge out of it. And then based on the request that a particular user has given, its main job is to its main job is to provide the its main job is to provide the responses based on the input. So basically, the generative AI not only deals with the textual format, but it takes all kinds of input and it provides all kinds of output as requested by the user. So there are popularly used some of the generative AI based applications, which are also based on the large language models like the OpenAI, ChatGPT, Google Gemini, and Microsoft Copilot are very popularly used some of the generative AI applications in the industry these days. So the AI, whatever the artificial intelligence, with the recent developments, though it was categorized into two kinds of AIs. One is the strong AI and other is the weak AI. So though the traditional AI exists from several years, with a lot of applications developed on top of it, it was considered or it was categorized into the weak artificial intelligence, and the mainly because of the reason that it was categorized as a weak artificial intelligence is because of its applicability. So the applicability of any traditional AI based application is narrow in the nature, and narrow means it is only designed to perform a specific task. For example, if you take a if you take a computer chess programs, or if you take any artificial intelligence based chess agents, so their main responsibility is to defend or play chess based on the rules that it has understood, or based on the rules that based on the rules on which it was trained. So it cannot do any other task apart from playing chess with an agent, or playing chess with a human. So but it becomes an expert in doing that task, but unfortunately it is mainly the scope of its application is only to play and finish that game. So the scope of the weak AI is narrow in nature, meaning it is only specific to a particular task. And though it is used in wide range of applications and in various domains in the landscape of AI, the problem is it is vertically so the weak AI domain is vertically developed but not horizontal, meaning it cannot span across different types of meaning a single application cannot span across multiple domains. But weak AI or the traditional AI is used mainly in different types of applications like speech recognition, image processing, and natural language processing (NLP) models. Whereas the generative AI applications or the artificial generative intelligence is strongly considered as a strong AI because of its cognitive capabilities of mimicking human brain to create something new. So it will always, whatever the task you give, like whenever you train your model or whenever you train your GPT with some images or some text, so whatever kind of inputs you give, it will be able to respond you. Like if you take a chat GPT application or a Microsoft Copilot, so what not everything, like starting from alphabets to complex problems in algebra or complex coding techniques, whatever input you give, it will give you the appropriate response based on the user input. So the scope of this generative AI based applications is large. It is widely spread across several domains, and the scope is also huge. So that is the main reason why the generative AI applications or the generative AI is considered as a strong AI when compared to the traditional AI. So the primary difference or the primary objective of considering the traditional AI as a weak AI is because of its applicability to a specific task, and it is mainly based on the hypothesis based and the rule based artificial intelligence or a rule based training. So when it comes to the strong artificial intelligence or the generative artificial intelligence, the reason why it is categorized as strong AI is because of its learning capabilities and because of its wide applicability across several domains and because of its response across various inputs, irrespective of the input. It used to provide some answer to the user, and it is going to perform its task, which is using some cognitive capabilities and trying to mimic the behavior of the human brain. So there is a lot of confusion, or there is a lot of buzzwords. Like, there are two buzzwords which are really creating a lot of confusion across the researchers and across the uh, uh, students of the computer science. So one is generative AI and other is the large language model. So let's discuss about the difference between a generative AI and a large language model. So a generative AI is trained based on different types of inputs, and it can be able to generate different kinds of output. Like, if you give a text, if you train your generative AI model using the text, basically it will respond you in the form of a text. If you train, or if you train some images or some audio files or some video files, it will try to understand the audio files and video files, and it will try to provide you the response even in the text format or even in the desired format. So the user has ability to choose his option, using which he can receive the response from a particular generative AI model. So the generative AI takes many types of inputs and provides many types of outputs. But coming to a large language model, it will always take a text-based input, and it will provide only the text type of output. So this large language model is usually trained on the large textual data, large textual corpus, and it will try to understand the complete corpus, and it will it will provide outputs from the textual from the trained data. So, and so there are some generative AI tools that we use while developing or while training a generative AI based application. But whereas the large language model, it will, so the main concept is based on the parameters of the model, and it will depends on the text that it is producing. The generative AI applications are usually built using the LLMs. So generative AI is nothing but a kind of generative AI applications that mainly deals with text are kind of large language models, or they're also called large language models, and they're typically built using the machine learning models. So foundation for in generative in large language models, so the foundation for text-based generative AI tools like chat GPT are considered as the one of the significant applications of the large language model. So the main difference between a generative AI application and a large language model is, right, so generative AI application can take any type of input and it can create any type of output, whereas in a large language model is always trained using the textual data, and it will provide you the textual output. So that is the main difference. And so generative AI applications that mainly deals with text are a subset of the large language models, or they are also called large language models. And so whenever we develop any generative AI application, there are some objectives why we are developing these applications. So the main objectives of these generative AI applications is, right, so we always tries to create a model or a AI model that works as close as to the human brain. I'm not saying they can replace the human brain, but eventually at one point in time they will be better assistants to the human. So they are better human assistants rather than replacing the human. So the main objective of any generative AI application is to obtain the cognitive capabilities of human brain for the tasks like problem solving and decision making, and to replicate the output like human brain, like how a human does for any decision making or any problem solving applications, right? How a human brain or how a human decides upon the decision, or how he's able to solve a particular problem, right? So any generative AI application aims to do the job that a human is going to perform. So that should be one of the main objectives for the while developing any generative AI application. So we should always tries to attain or tries to achieve some cognitive capabilities for that particular model that we are developing. And then when we are developing these kind of models, right? So we always tries to maintain the ethical and responsible standard. So it should be legal, it should be in a correct way. So we always have to maintain the ethical standards and the responsible standards. So ethical AI and responsible AI are the two terms, and the trustworthy AI are some of the subdomains that are developed around this generative AI to make sure every generative AI application that is developing is maintaining the ethics, is responsible, and is maintaining the security and privacy. And it is also giving it should also give an impression that it should be a trustworthy application. So there should be no harm, or there should be no side effects while using or adopting this particular AI model. So whenever one is going to develop a generative AI model, so all this maintain ethics and responsible AI and trustworthiness are the important standards that one has to maintain. And then another objective is like allow continuous learning. So the model should learn continuously, and it should try to understand from the previous experiences. It should try to understand from the previous observations, and then previous experiments and the observation. So it has to be continuously learned using all its past experiences and the observations. Then right now, whatever the models that they are available, right? So they are not very much good at understanding the human facial expressions, and they are not very good at socializing. So they are not context based. So meaning when we say like if we take a human being, right? So the way human communicates is all depends on the context and depends on the situation. So if it is a happy situation, so humans will respond in one way, and if it is a kind of unhappy situation or a bad situation, he'll respond in other way. And most of the times one can understand his mood based on his facial expression. So whether he's happy, or whether his mood is upset, or whether he's not doing good, if he's having some sickness. So based on the facial expressions, from the human facial expression, one can easily identify what is happening. But the biggest problem with these generative AI applications is we cannot determine that, um, at least in the whatever that exists now. So we cannot determine that, because they are not context based, and they are all training based, and they will always try to give response based on whatever the data that they train. So they do not have emotions, or they do not have more uh, and they are not very much capable of socializing like how a human interacts. So that is also one of the main objective that one has to focus on while actively working on the generative AI applications. Yeah, and there are also certain limitations while using these generative AI applications. The first thing is high computational cost. So a lot of hardware and lot of computers are required for developing a generative, not for developing a generative application, but for hosting it and for the training. It needs a lot of data, a lot of information it needs. So computational cost and training wise, it is a huge process. It requires a lot of efforts, both cost wise and manpower wise, to train the generative AI model. And this generative AI model is always context, they are always context dependent, as I mentioned. So basically they are masters at whatever the context that we have given, they do. So meaning they do the diverse tasks. But again, for example, if we take so don't get confused with the concept of weak AI and the context dependent. So the weak AI is, or the traditional AI deals with the narrow, the scope of the traditional AI is narrow, but the scope of the generative AI application, or the generative based AI, or the strong AI is wider within within the given context. Meaning, let's take an example where developing a chatbot. So when we are developing a generic chatbot like chat GPT, so what will happen is, it will, so you you give any input, like you can ask questions from mathematics, you can give questions from biology, or you can ask Python programming, or you can ask Java programming. So whatever, or you can ask anything. You can ask about the stock market, or you can ask about latest developments in particular area. So whatever the input that you give, it will respond to you within that context. But if you have a text-based, meaning if you have a text-based large generative AI application, and if you try to interpret, or if you try to give an input image or an audio file as an input, right, it is not able to respond. So because it is not in the given context, so we are developing a text-based, textual context-based generative AI application, and we are asking a different kind of output. So context meaning the scope and the type of application that we are developing. So again, privacy, and so in most of the generative based AI applications like chat GPT or Copilot, right, so they are all privacy, and we have the privacy and ethical concerns. Let's say if you upload your payslip to the chat GPT application, and if you make your your GPT application as public, so, and if you train your payslip using the GPT, so it will always reveals your salary. So it do not know what to reveal and what not to reveal. So that is where companies like Google and Microsoft, they are all coming with the concepts around generative AI, as I mentioned earlier, like the responsible AI, trustworthy AI, and ethical AI, to make sure the security and privacy is safe uh, with these generative AI based applications. And then hallucination, meaning many times it gives a wrong input, based on the given input, it many times it gives a wrong output. I can show you some of the examples in the latter slides. Within the given context, when you give a question, right, so what will happen is, it will based on the input, it is not very much the response of this generative AI based applications is not very much correct. So it also failed in certain cases. So it is not always trustworthy to be based on these kind of applications. So uh, the effectiveness, evaluating the response of the generative AI based applications is also necessary, is also one of the open research problems. So we have to eliminate the hallucination from the responses that a particular generative AI model as much as we can. So let's go through one of the primarily using ChatGPT application called OpenAI ChatGPT. So this ChatGPT GPT is called a generative pre-trained transformer architecture. So it is mainly, the application is mainly developed on the transformer architecture, where it is based on it is an advanced AI chatbot which is mainly developed by OpenAI using LLMs. So based on the LLMs, and it is mainly it is a chatbot which mainly tries to interact with the human being. I mean, yeah. So basically, like it can start in conversations with you and it will follow up all of those conversations. So it will continue the conversations like how a human does, but still we have to always make sure the response of this the GPT application is always correct. So it is scaled on large computers, and the the training data is huge for all of these for these GPT based applications. I think the billion parameters were it is a billion parameter trained model with large input text corpus that got trained, and the development of this GPT application is mainly the API based development. So when dealing with any GPT applications, the important concept is called prompt engineering. A prompt is nothing but the input that we are giving to a GPT application or a large language model. So the input that we are feeding to any LLM is called prompt, and the response or the output that we are getting from that LLM for the given prompt is called response. So in prompt engineering, right, basically in any generative based AI applications or any LLMs, uh, the input is very important. So if you provide a proper input, it will try to give you the output that aligns with the given input. So if you give an invalid input, or if you give an incomplete input, right, so it makes your system confused, or if it makes your GPT application confused, and you may not get the accurate result every time. So prompt engineering, where fine tuning the input is always an important step. So where we design the input every time. So there are also some techniques that exist in the literature for fine tuning the input to get the optimal and correct results. So always when we are trying to feed the input to any large language model, right, so what we have to do is we have to include the context. So we have to always talk about the context that we are trying to do, and then we always needs to be clear and specific while providing the inputs, and then do not provide an inappropriate content, or do not provide an incomplete content while giving any prompts to any GPT based applications, because it will try to confuse, I mean it will get confused, and it will also confuses its output. Yeah. So coming to our research, so basically we are mainly focusing on evaluating this LLM based generative AI applications, because so there are some issues with the response that this LLM based generative AI applications is generating. So they are not accurate every time. So there are some issues. So there is a need to evaluate the responses of these LLMs. So how we can make sure that the LLM has given a correct output for the given input. Okay, so we are mainly focusing on this one of the research problems. So this is our one of the research areas where we are trying to develop a framework using using the software testing techniques to develop um, a mechanism for evaluating this LLM based generative AI applications. Right now, our scope is mainly to confined to the textual based LLMs. So we are not focusing on any image or audio based LLM set. So our primary approach is to focus mainly on the LLM text based generative AI applications. And then so basically most of these LLMs or the most of the generative AI applications, the main scope of these applications or the main objective is to develop a system that has human cognitive capabilities. But most of these applications are developed, or most of the existent applications are developed on the traditional von Neumann architecture computers. But there are also architectures called there are also a specific architectures called neuromorphic hardware, which is designed based on the human brain. So the processor itself is designed from human brain's inspiration. So it is also called the brain inspired computing. So when we use this brain inspired hardware for developing a large language model, right? So one of the advantages we will get is the help from the hardware. So on chip learning, the help from the hardware. So right now, all of the LLMs that exist in the literature, right? So they are mainly yeah, sorry, they are mainly based on the von Neumann architecture, and they mainly respond based on whatever the data that they trained with huge computational efforts, right? So they'll give outputs based on that. But when we adopt the brain inspired architectures into our generative AI development, right? So the on chip learning will help us to achieve some cognitive capabilities to our large language model. So here we will also get help from the hardware uh, while taking decisions or while giving up the output. So that is the main advantage that we get using the neuromorphic hardware or the brain inspired hardware. So this is one of the research area that we are mainly focusing on. So so why evaluation is important? So most of you know Professor Stuart Russell, who is a pioneer in artificial intelligence. So I got an opportunity to meet him in the year 2017 at his lab with my PhD supervisor. And after that, we both connected through LinkedIn. And whenever I have any kind of basic questions in the artificial intelligence, I'll ask him, and he'll respond. He'll respond, and I always wonder, such a great man. So there is no point in responding to a researcher like me, but he always tries to give his opinion on any of the topics that I ask. So recently, last year, I have interacted with him when the when everybody started running behind the chat GPT or the generative based OpenAI applications. And so I asked him his opinion on chat GPT, and then he provided some response to me, basically like the question that he asked the OpenAI chat GPT is, which is bigger, an elephant or a cat? And the response is, an elephant is bigger than a cat. And which is not bigger than the other, an elephant or a cat? In neither an elephant nor a cat is bigger than the other. So if you see the first question and the second question, the system itself is contradicting while providing, the GPT application is contradicting itself while giving the response. And the third question is like, what is the largest even number? So the largest even number is something, and even if we add 2 to this particular number, right? So that again, that will become a largest even number. So the largest even number is a never ending process. So we cannot conclude that a particular number is the largest even number. But the system is able to decide upon that, and the ChatGPT has given one number as the largest even number. And then this is an interesting question where I started with 20 euros and gave 10 euros to my friend. How much do we have in total? So in total, we have only 20 euros, but the system has given 30 euros. So these are some of the examples of the hallucination where, within the context, if your question is tricky or if your question is having some logic, your ultimately the GPT application is able to fail while providing the correct response. So this problem of hallucination was improved a lot in GPT version 4, but we still have pitfalls in some of the prompts. So whenever so the main thing with the GPT applications is they can provide they can provide output for any given input, but they do not apply any logic, or they do not apply any analytical capabilities while giving the response for any given input. So it will always tries to provide you some input, but it do not care whether this has a logic or this has some analytical capabilities, or whether is the question tricky. So it do not tries to understand that. But coming to a human brain, when we ask a particular question, so human brain will first always tries to understand what is the logic, or what is the, and it will always tries to analyze the given question and it will respond. So this is one of the research, one of the issue where this GPT based applications are failing. So it has to understand the logic, and it has to understand the analytics in any given prompt before it should respond. But right now, whatever you have trained, it will try to interpret from the trained data, and it will try to provide you some output. So this is one of the area where one should focus on. And this is one of my interactions with the GPT based applications. So I have asked positive or negative, which is best. And then the model has given an outcome saying positive is always best. So then I have asked, like, do you think the COVID positive is better? Then it said no. It said COVID positive is not better. And what it said is like, in this case, a negative result is best. So as I mentioned, right, so it do not apply any logic or anything while responding to our questions. But so this is so these are some of the things that it needs to improve. And there is also a paper called Mathematical Capabilities of ChatGPT, which also talks about some of the capabilities that GPT can do in the area or in the domain of mathematics, and some of the things that it cannot do in the domain of mathematics. So that is also one of the very good research area where one can focus on how a GPT application is mathematically strong and how we can improvise it. So there are several techniques, or there are several frameworks that exist in the literature to evaluate any large language based generative AI, LLM based generative AI application. And some of them are like, these are the mainly used benchmarks. One of them is called GLUE, General Language Understanding Evaluation, and the other one is the Super GLUE. And there are other frameworks, and these frameworks are mainly based on natural language processing. So they are all mainly based on the NLP techniques and some of the statistical evaluations. So they all work in a different way while try to evaluate any LLM based model, but these are not scalable. These, whatever the models that are not that are exist in the literature, they are not very scalable, and they are not very much handy to interpret large amount of data and get the evaluation done. So we are thinking of developing a framework based on the software testing techniques. So coming up with the using the software testing lifecycle. So we are planning to develop a generic framework for the LLM based model, and depends on the context and depends on the type of the application. So we are planning to, I mean, still we are in the analysis and we are still in the research phase of this particular problem, where we are trying to customize that generic framework for the applications depends on their context. So here coming up with, so the main objective is to come up with a functional testing framework which should understand the context of any given application and then evaluate the response using one of the existing techniques, and then testing this model using the equivalence class partitioning, meaning generating large set of valid inputs and large sets of invalid inputs, and evaluate our model on how the model is responding to the all the set of valid classes and valid inputs, and then evaluating our model on how it is responding to the invalid sets, and then defining some predefined outputs, and comparing the generated output, expected output, and the actual output using some types of measures like similarity index, like the cosine similarity or the Jaccard index, using those some of the statistical metrics. So we are planning to evaluate the model. So right now we are trying to apply for funding, so I cannot disclose more details about how we are planning to do this research in detail, but this is the high level overview where developing some functional testing framework, and this functional testing framework is within the limits of the given context, where we will evaluate the accuracy of the response that was generated by the model for a given prompt, and then how we are dealing with the valid and invalid inputs using the equivalence class partitioning technique. Then let's go briefly about the brain-inspired computing using neuromorphic hardware. So as I mentioned, neuromorphic computing is one of the recent developments in the era of computing, where the computing is mainly developed based on the architecture of human brain. So inspired by the human brain's architecture, so the neuromorphic hardware is developed, so which is able to mimic and parallelize as many tasks as possible by with the view of the energy efficiency. So the neuromorphic hardware, it mainly developed on basis of the spiking neural networks, so which is also called the third generation neural networks, where where the data or where the communication happens in the form of spikes, signals, like how a communication happens in the typical human brain. So in human brain, so most of the communication is happened using the signals, and in the similar way, in the spiking in the neuromorphic hardware, which was developed using the spiking neural networks, the communication is happened in the form of spikes. Let's see how it is different from the traditional von Neumann architecture in the latter slide. So, and it is mainly neuromorphic hardware is mainly used in tasks like artificial intelligence, and it is mainly used in image processing and pattern recognition tasks. So it is widely used. So there are several applications in the domain of natural language processing, image processing, and AI, where the applications are developed using the brain-inspired computers, like using the neuromorphic hardware, and the models show some kind of cognitive abilities while mimicking the human brain for performing that particular task. So this is the main difference between the traditional von Neumann architecture and the neuromorphic architecture. So if you see in the von Neumann architecture, we always tries to give the input is given the processor will always take input in the form of binary ones and zeros, and similarly we'll get the output in the form of binary zeros and ones, and it is also sequential processing. So all the processing in von Neumann architectures is done using the sequential processing, and there are certain processors which has the parallel processing capabilities like dual core, but still the communication takes in the form of bits and bytes. But coming to the neuromorphic architecture or the neuromorphic hardware, so there are some hardwares that are widely available called Spinnaker and Acadia. These are the mainly available Spinnaker architectures. And so if you see this, right, so you will give always the input is in the form of spikes, and these spikes will be generated using the spiking neural network. So the spikes will be input to your processor, which so you have a spiking neural network. So the spikes will be input to the processor, and the output will also get so your output is also in the form of spikes. And these are all the spike processing will be done in parallel, like how a human brain reacts to parallel things, right? Similarly, it takes a lot of parallel tasks, and it do lot of parallel processing at the chip level itself. So this is the main difference between the von Neumann architecture and the neuromorphic architecture, where in neuromorphic architecture, most of the communication is done using spikes, and in von Neumann architecture, the communication is done in the form of bits and bytes. So basically, most of the LLM models or the most of the generative AI applications that we have in the literature, they are all developed on von Neumann architectures. So they always take bits and bytes. I mean, whatever the input that you have given, it will eventually convert it into bits and bytes, and then you'll get output in the form of bits and bytes, and again it will be translated into the whatever the language that we have given. But coming to the neuromorphic hardware again, so the main advantage is everything happens in the form of spikes, and the spikes will be generated using the spiking neural network. So there is an advantage that we can achieve some kind of human cognition, or we can achieve good human cognition rate for any model that we are developing on the neuromorphic architecture. So for LLMs, or the for generative AI based for the large language model based generative AI applications, especially the applications where we generate text for the given prompt. So in order to achieve some logical and analytical capabilities, the chip level learning, where mimicking the functionality of the human brain, will help us a lot. So will help us a lot. So we are trying to develop a neuromorphic brain inspired large language model using the neuromorphic hardware. So where we are going to train our model on the neuromorphic chip, and then try to see how it is responding and what cognitive capabilities it achieved, and how the processing is done in parallel, and how the processing, how the output, so the accuracy of the output when compared to the accuracy of the human brain. So we are planning to develop this model on the brain inspired computing. And as I mentioned, so we are also applying for funding on this project, so I cannot disclose more details about how we are doing and what we are doing in order to develop a brain inspired large language model. But for the readers who are very much interested on neuromorphic hardware and how some of the NLP tasks can be done with cognitive abilities, so you can always refer one of our latest papers called neuromorphic sentiment analysis using spiking neural networks. Is one of the sentiment analysis model that we have developed on the brain inspired computers on the neuromorphic hardware. And we got this neuromorphic hardware. We have used a hardware called Spinnaker from the Human Brain Project of European nation. So it is free. It is widely available for free now. So what we have to do is we have to, through our institute, we have to request the admins of Spinnaker to get a license. So what they will do is they will grant a license for the hardware. So using the hardware, where what you can do is like we can always develop some cognitive or some NLP, some applications with the cognitive abilities, and we can always run those up. We can always train those applications on the brain inspired chip or the neuromorphic chip, and we can always try to see how close we are while achieving the output with respect to human brain. So we have developed one model called neuromorph sentiment analysis model, which we trained on the IMDb movie review dataset, where for a given movie, the model will respond with its review, and we see, I mean, we evaluated how this particular review is aligned with the human brain's response. So we did some metrics on in our paper, and more details about our work, and more details about the neuromorphic computers, an introduction to neuromorphic hardware, and introduction to spinnaker and spiking neural networks is can be found in this particular paper. So let's go through how to build our own GPT using the chat GPT. So so there are two ways we can develop our own GPT. So let's see, the first way is right. I'll log off from here. Okay. So when you open the chat GPT, right? So chat.openai. So we have an option to choose which GPT we can use, whether GPT 3.5 or GPT-4. So GPT-4 is the latest one, which has addressed most of the issues that we are seeing in the uh, hallucination or the invalid responses. It addressed most of the issues. So let's log in. You can log in with your Google account. Yeah. So if you so here if you see, so there are some options. So I have upgraded to the premium version of the GPT. But if you log out and see, I'll use a different account. So if we use an so if we use an sorry, I have a sorry, I have a bad throat infection, but that's fine. Yeah. So if we see this right, if we don't have an upgraded plan, it will provide an option to upgrade. So there are two types of plans that are available. One is the individual plan, which charges $20 a month, and other is a team plan, which charges $25 a month. But yeah, so if you are first logging and if you want to build your own GPT, basically what you can do is right, you can upgrade to whatever the plan that you want. But if you want to use a free plan, that is always fine. But there is no option to develop your own GPT. Okay, so let's see. I'm using the plan that I have. I mean, I'm logging in with the account with the plan. So here, if you go to, there will be a link. If you have upgraded, right, it will show you a link called My GPTs, and just create a GPT, and you can upload like whatever, any PDF file. So I'm training a PDF file, our recent paper as the PDF file and I'm uploading it to my GPT. So I just given this PPT as an input, and so the file has been uploaded and it is asking what is the desired behavior or focus of your niche GPT. Okay, so I'm just so I'm asking this model to understand. So it is trying to upload that particular file, and then yeah, so it has understood everything. So it completely understand the paper. So if I go to this screen and if I ask, so if I ask who are the authors of this paper, it will provide responses. See, so when I asked about their affiliations, it provided the author's affiliation, and then I asked the main objective of the paper, and it provided the main objective. What is the objective of this paper? And so the following are some of the performance metrics like accuracy, energy consumption, membrane portal, and these are some of the performance metrics that were evaluated in this paper, and it provided information about all of this. Okay, but let's go to the GPT and ask the same question. This is the original chat GPT. Let's see how it responds. So see, it do not have access to that particular paper. So this GPT, it is not able to identify this particular paper. So the chat GPT do not have scope to get this paper. But if we train our GPT with this model, right? So my context in this particular GPT is only to focus on our latest research paper on the neuromorphic sentiment analysis, and it has provided response to it. It understood that context clearly, and it is providing answers to all of my questions within that context. The context of chat GPT, the original GPT, is different here, and it may not have complete information. I mean, see, this paper is personally, it belongs to us, right? So it may not have that scope, or it may not have that access to personal information while providing the response. So this is specifically, this context is belongs to us. So it do not have access to that particular context. But if you ask a question like what is SQL, it will provide some information, because the context of SQL is public and it is available for everybody, right? So yeah, so you can upload any kind of PDF file and you can get your model trained, and you can understand not only the PDF, but if you have the appropriate license, we can also upload any kind of audio file or the video file, image file, anything, and we can train our GPT model, and GPT model will provide responses. And then these are some of the configuration settings where we can name our own GPT. We can add some description, instructions, and then there is also we can also provide some access, like see this one, the scope of this is only me, but I think there is we can also provide our the scope of this GPT to be accessible across public, so that anybody can use this GPT. So this is how we create a GPT using the OpenAI GPT UI. So just all is we need to have the appropriate license and then go to the create GPT, and you can upload whatever the information that you provide. Like you can give lot of text, you can give your thesis, so it will understand everything from your thesis and it will give the response, or anything you train here, it will provide you the response, and then we will make the scope of its scope of the GPT, like whether it is available visible only to our to team, or only to personally to you, or only for everybody. So we can change everything based on the requirement. So the other way we can create this GPT is right using the API keys. So using the APIs and using the code. So the Open API API is publicly available. So all of this is the documentation for that. So basically, if you see the reference, right, we can it is all developed in Python. So just we have to install the pip install OpenAI, and we can start writing some Python programs using which we can always develop our own GPTs using the code. But in order to do that, we always need is an API key. So when we select the API option, just go to the API key and create a new secret key, where you can give any name, which is optional, and you can also select your project, and then you can do all settings. And if you create a key, right, it will give you an authorization to access their API. So you can always copy and use this key to access the OpenAI thing. Okay, so let's go to the so you can create your projects here itself in the editor, and you can create whatever the GPT that you want using the code, and there is some limit. So there are some cost limits and all, and they are also providing some docs where it is all like the help center, where you can see what are the APIs and how we can use. So these are some of the audio endpoints to understand the audio for the create speech and everything. And this is the chat endpoints, where you can develop a chat bot using Python. So here they provide the Python code and all for developing. So this is the other way to create our own GPT. But in when we are creating it using the API keys, right, all we need is we need to have access. So in order to get the access, we need to create a new secret key. Yeah. So this is how we build our own GPTs. So we can always play and we can always try to understand what is going wrong with the GPTs, and we can formulate some research problems from there itself. Yeah. So so that's it from my side. So yeah. Do you have any questions? If anyone have any questions, like feel free to ask.
Hi, sir.
Yeah. Yes.
This is Nitish Kumar from this side.
Okay. Yeah.
Sir, actually your session was really awesome.
Okay.
Sir, you can switch on camera, sir, Nitish garu.
Yes, ma'am. Sir, I just wanted to know that this for a specific task, how can we select a particular LLM? That what I wanted to know, sir.
Sir, can you come up again?
Am I audible right now?
Yes. Yeah, you are audible.
Actually, sir, I just had a query like, let's say we have any particular task to perform. How can we know that whether which particular LLM we should use in order to get desired result? Like we have lots of LLM available freely right now.
Yeah. So, sir, here the concept of all LLMs is same. I mean, if you use Google Gemini or Microsoft Copilot or OpenAI ChatGPT, right? So for any given question, their response is same. Okay. So it all depends on, so if you want to develop a own LLM or own GPT, right? So you have to choose or you have to decide on your own data. So whatever the training data that you want to give to a particular LLM, right? So for example, okay, let me say, so I have a IMDb data set, or I take some data set from the machine learning repository. So what I can do is I can develop an LLM and I can train using my own data set. Okay, I can develop an LLM using my own data set. So whatever the data sets, whatever the LLMs or whatever the LLM applications that are exist, so they are already trained on billion parameters of data. They are already trained using billion parameters, and they had lot of data that was provided while training. So they'll give always they will give the response for any given question. So if we want to develop a particular context, let's say let's take GMRIT as a context. Okay, so if you ask OpenAI or any chat GPT application about the GMRIT, right? So let's type it here. So it is providing, right? Let's see. So you do not have the latest details, right? So maybe what you can do is, right? So see, GMRIT, since it is a very renowned institute, right? So it can provide information about it. But it is affiliated with Jawaharlal Nehru, JNTU, Kakrada, and it is giving all of that information. But when you ask a specific question, who is the head of the Department of Information Technology, do not have that answer. So if you want to develop a GPT, right, what you can do is you can, which is internal to the GMRIT itself, maybe you can train all of your faculty profiles, faculty data, and all of your students information, faculty publications and all. So if you do that, what will happen is if you ask any questions from whatever the data that you have trained, it will give you the response. You understand, right, sir? So here it is I mean, the context of your own own GPT is within your own data. Okay, so in order to develop an LLM, you can use, in order to develop a large language model, you can use any of the APIs. Like you can use OpenAI, or you can use uh, Microsoft Copilot or Google Gemini. It is like developing an application in our own language, sir. Whenever you want to write an algorithm, right? So you can choose either you can write it in C, you can write it in C++, or you can write it in Java. Okay, so in a similar way, these are three different kinds of LLM based GPTs, so which followed the same architecture of a pre-trained transformer architecture, and they'll give response. Okay, so if you want to develop your own thing, you can always check whatever it is affordable to you, like based on the cost basis, whichever is cheaper. If Microsoft or Google is providing you some free access, what you can do is you can take that free access, you can feed all of your data, and you can come up with your own GPT.
Sir, can we go a little bit deeper on this? Actually, let's say a basic task I have, let's say a basic text summarizer I want to use. So I want to choose some, let's say, any LLM. For the example, we have to take like according to our resources. We are not a big company. Like if a person we are talking about, like individual person. So first of all, we need to take care of the like how much parameters is available. Like GPT, we can't train the whole GPT, right, sir?
Yes, yeah.
So let's
See,
say,
my question is, sorry to interrupt you in the middle, but see, sir, we already have a trained model, right? We already have a GPT is already trained on using billions of parameters on lots of data, right? Why again we want to train a model?
yeah, right, sir. We just need to fine tune the model
Yes, exactly.
For our specific purpose. So my thing was like every good model around having more than 100 billions of parameters as of I am able to know.
Yeah, true.
So for example, let's say I'm talking about for a basic model, let's say Bloom I'm talking about. So let's say I want to have a task of, let's say, text summarizer, but how can I know that whether that particular model is able to do that particular task or not? That is what I wanted to know in this set.
Okay, whether a particular model is able to do some NLP or NLU tasks based on the given input, right, sir?
Right, sir.
Yeah, I mean, so maybe like if you want to do a part of speech tagging or a sentiment analysis model, so you want to choose which model is best, or right?
Right.
So that actually again to answer that question, so which model is best for which purposes, again we have to go through the literature survey, and we have to identify the best model that fits our needs, sir. So there is no direct way. There is no direct way we can choose a particular model, because all of at a high level, if you see, all of these models respond in the same way for any given input, as far as I work, right?
Yes, sir. Yes, sir.
Yeah, so maybe what we have to do is, right, so it all again depends upon going through the literature survey and identify the best model that fits our needs, and try to work on that.
Okay, sir. Right. I think we should use brute force technique. We should try 4-5 models, and based on that, we can get our.
So basically, yes, sir. So instead of directly using what is available, right? So they are already doing that a particular task. Okay, let's say if you are developing a part of speech model or an NLP model, right? So if OpenAI, GPT, or Microsoft Copilot is already doing that, so there is no novelty in the task that we are doing using this particular LLMs, right? So maybe what we have to do is we have to think differently by addressing the existing issues in the LLM based model. Maybe hallucination, right? If you are developing a sentiment analysis model, and let's say you're giving you're asking for a movie review. Okay, I mean, this is one of the test cases that you can take. Okay, so there were, let's say you generally give the review of Spider-Man movie. Okay, So if model responds with some kind of review, we don't know which Spider-Man version it is,
Right.
right? So maybe in these aspects, we can always fine tune.
Yeah,
Okay.
I am also able to find a problem like it
Mhm.
is not having access like compilers we have. Like if we want to implement any code on this, it might get a wrong result. Whatever I tried with this, so
Okay.
this is also one problem I'm able to find on this GPT.
Okay. Yeah. Okay. Okay, sir.
Sir, one more thing. Can we have a vision language vision model on this? Like, will it be going to boom like this? Or what?
Yes. So yeah, actually, that is what now the chat GPT-4 and everything is concentrating on. So we also have the vision based, the image based, and the audio based, and different kinds of input based LLMs that are developed, and various organizations and various researchers are coming up with different kinds of GPTs for different kinds of inputs. Yes.
Okay, right, sir. Thank you for
Yeah.
your
Yeah.
information.
Yeah.
Thank you.
Yeah.
Lakshmi ma'am, unmute Shilpa ma'am, na? You want to ask? So, Mr. Raghavendra,
Yes. Yes, madam.
session is truly informative and research supportive, and the flow was very clear. Thank you so much. We learned a new thing today, how to have our own chat GPT also. Right? Like lot of key things are there, generative AI versus LLMs.
Yes.
It's all good. I hope participants enjoyed the session. We're expecting some of the participants. We welcome you for some queries or feedback.
Good evening, sir.
Yes, madam.
Am I audible, sir? Yes.
Yes. Yes. Yeah.
Thank you
You are.
for the great session, sir. So my query is, you elaborated the Spinnaker software, sir.
Yes. Yes. Yeah.
I think your team is working on sentiment analysis.
Yeah. Yes. Yeah.
So my question is, what kind of applications we can do with the Spinnaker?
So mainly the
Means
Spinnaker.
what kind of data we can able to give as an input? Is it only text or images or voice or audio like that?
So right now, okay. So basically, the let me explain you how a Spinnaker architecture works. Okay. So right now, what we are doing is we are creating a artificial neural network. initially using our input data, and then we are converting that artificial neural network model. So after the artificial neural network model is created with
Means our data is in any format is okay, sir, for that architecture, means text
no.
or images.
Okay, so
It's
so
the
first
same.
we are creating the artificial neural network model, and then we are converting it into the spiking neural network model.
Okay.
Okay, so whatever the inputs an ANN model will take, right? All of those inputs will be supported by the spiking neural network model.
Okay, sir. Okay. So, and one more thing is, so like for example, when we use the MATLAB or Google Colab, we have a trained models are there, proved trained models are there.
Yeah.
So, do we have such kind of models in Spinnaker?
Yes, so there are some proved models, but those models are mainly in the area of image processing.
Oh, okay, image
Okay,
processing.
so yeah, so basically that is one more research area where if someone is interested, how we can take advantage of. See, there are a lot of artificial neural network based models in the area of machine learning and deep learning, right? So how we can bring those models to Spinnaker hardware and how they are efficient and accurate when compared to ANN model is one more research area where we can also add some kind of cognitive capabilities for those models.
Yes. Okay. It is impressive, sir. It is impressive. So definitely, I'll try that
Yeah, yeah,
Spinnaker architecture.
yeah,
Thank you, sir.
yeah.
Thank you, Shilpa ma'am. Thank you, Shilpa ma'am, for your question. Any other queries?
Thank you.
Uh, this is Dr. Shamgant from University of Technology and Applied Science. Thank you, Dr. Raghavedra, for the insightful session, and it was very informative. I have one doubt. We are actually working on the explainable AI related to the emergency medical settings. I would like to know whether the generative AI is acceptable in the medical settings. Usually, the medical practitioners they won't accept AI as a recommended tool, as in there is no transparency behind. So, explainable AI provides the transparency. What about the generative AI? Could you please brief on it?
Yeah, so basically, so there are some privacy and security and ethical issues with respect to any generative AI based applications these days. So when we are dealing with the medical data, right? So both privacy and ethical aspects comes into picture. So that is the reason why whenever recently Google when they are developing this generative AI based models, so they also came up with the concepts called responsible AI and trustworthy AI to address the issues that are aligned with security, privacy, and ethical aspects of the generative AI based applications. So if we go to Google generative based AI courses, right? So when we go to that courses, so there are courses that are specifically designed to that mainly focus on addressing how we can achieve or how we can develop a generative AI based application, taking the aspects of security, privacy, and ethical concerns into account, and how we can develop a model by satisfying all of these three areas of the AI. So it is always, I mean, the organizations are always, I mean, the big companies like Google and Microsoft, they are, whenever they came up with the developing the generative AI based application, they are also recommending to consider to consider the aspects of responsible, trustworthy, and ethical AI. So when I say developing any generative AI applications, considering all of these three is very important in order to use them heavily in our real-time applications, especially in sensitive fields like medical or transportation or banking sector. In any of these fields, if we want to use the generative based AI applications, these three things needs to be addressed, and these three aspects like the ethical, security, and privacy aspects need to be addressed before developing the actual generative AI based applications in those sensitive domains. So if you go to the Google generative AI based courses, right? So you will see it is not only, they'll not only teach, or they'll not only give information about the generative AI, but there are also courses that explains why the trustworthiness and why the security and privacy concerns needs to be addressed while dealing with generative AI. So they are very important.
Thank you for your clarification, Dr. Raghavedra.
Thank you, sir. Any more queries? Dr. Varalakshmi, ma'am. Can you please unmute yourself and ask the query?
Yeah, Dr. Raghavedra, it's a very insightful session. Like I'm from great institutions which are dealing with management students. We encourage students to use ChatGPT. And my question to you is, whenever they are using ChatGPT and creating some content, professors do not accept the content that is generated by ChatGPT. So, in order to encourage them, use ChatGPT for a very good content creation. What are your tips? What are the tips that you'd like to give the students of management studies? Not the coders. Like I'm not talking about the coding experts. These management students are non-coders. So, what are your tips for these management students for this?
So, for any for getting any kind of content, or for creating an effective content using Chat GPT, it is always important to focus on prompt engineering. So, prompt engineering, it does not necessarily deals with the coding aspects, but it always deals with fine tuning the inputs.
Yes.
So that is one of the areas which is also important, and that is the reason why in this entire GPT world, the concept of prompt engineering came into existence to address these kind of issues. So in order to create an effective content, I recommend efficient prompt selection. So whatever the input you give, it will respond. But if you fine tune, again, it will respond in a different way.
Yes, when we use the text analytics, it differentiates, like analytics will differentiate whether the content is created by the machine or the human. So,
Yes.
How is it ethical to use the content used by the machine and claim that it belongs to a particular student?
So again, it is not ethical in some aspects. Again, it depends on the context. Like, let's say if we want to submit a homework or an assignment, so if we ask GPT, it will easily do, right? And it will always saves time for the students. But it is not ethical in some context, but it is ethical in certain contexts. Again, it depends on the situation where we are using. Right? Let's take let's say if we want to have a consolidated report. Let's say if I trained the complete details of the GMRIT faculty and about their profiles and everything, if I develop a GPT model, and if I want to see if I want to pull some stats out of it, it is always easy method, right? So instead of manually evaluating, if I upload one PDF file to the GPT, it will give whatever the data I want in whatever the way I need. So again, it all depends on the context. But coming to students' perspective, or even in the research perspective, in recent days, there are certain incidents where the journals of Elsevier and Springer, which are Q1 journals with a very good impact factor, somehow the reviewers has missed that the content was generated by GPT. So the reviewers or the editors, they never gone through that article completely, but it was directly published. And in the publication, after it got published, right? So the introduction, the abstract, and everything is clearly showing how a generative AI based, how ChatGPT has generated those responses.
Yes. Yes.
So yeah, so definitely in the area of research, and maybe we can take inputs or guidance from it on developing. Let's say if we have writing if we have writing issues, or if we write something, if we find grammatical issues, in those cases we can take help of it to improvise our language, and we can fine tune its output, but copying as it is not recommended.
Can they refer, I mean, a site that they have generated this content from the ChatGPT?
Again, it is up to the editors or up to the staff or faculty. So in some cases, right, so basically when we are reviewing the research papers or when we are submitting the research papers, the editors are explicitly saying any generative AI based responses are not allowed. So even if we submit, if I get a paper for review and if I train all of that paper to the GPT, and if I ask for the review comments, it will be like a 5 minutes process where it will understand the complete paper and it will give the outcome of the paper or the objective of that paper and what are the limitations of that existing work, or the complete opinion on the paper, and I can directly submit in the journal's reviewer site. But it is not recommended by the editor, so the editors itself, they are not encouraging. But some editors from Springer journals are what they are suggesting is you can take the help of this GPT or any AI based application to review the paper, but you make sure you just take the help and fine tune the response. So
Thank
that
you
is the
so
reason
much.
why GPTs are mainly, they are better human assistants rather than replacing human.
Thank you so much for the elaborative answer.
Yeah.
Thank you, ma'am. Thank you. Thank you, sir, for your valuable informative session. Your session is very informative to all the participants. So, today, I'll conclude the session with all the summary points. What are the points discussed in this session? So, today's session started with the definition of artificial intelligence. What is artificial intelligence and how it is generative? What is generative artificial intelligence and how it is compared with LLMs, and objectives of generative artificial intelligence. And sir again discussed about OpenAI, ChatGPT, in what is the prompt engineering and why, how evaluation is done, how it is important, what are various existing evaluation techniques. And also he explained about neuromorphic computing and how brain inspired computing using neuromorphic hardware, and how is it different from our traditional wisdom, and how to build our own chat GPT, our own GPT. So today's session, I hope all the participants enjoyed the session and have gathered a lot of information from this session. Thank you, sir. Thank you, Raghavendra, sir.
Yeah, thanks
Vasudha,
for
madam.
providing this opportunity, madam. Yeah.
Thank you, sir.
Thank you.
Thank you very much, Raghavendra Kumar. Even in
Thank
your
you.
busy schedule, and time is not comfortable even then.
Thank you, madam.
I feel like the session was very interesting for the participants. Lot of queries also there. I think for their future research, it definitely helps them. Okay,
Shall
ma'am.
we close the
Left, it
session, ma'am?
seems.
Okay, thank you, sir. Thank
Recording,
you all the
recording,
participants.
recording. You stop it, ma'am, first.
The participants, today the session will be closed and tomorrow at sharp 3 p.m. we'll start the session. Tomorrow's session will be by Dr. B. Santosh Kumar, sir, from Head of CSC Department, Guru Nanak Engineering College. So today we'll tomorrow we'll start the session sharply by 3 p.m. Thank you.